but I'll make sure that that is good to go here in a couple of minutes. Again, reminder, I have muted your phone just to cut down on noise. If you need something, if you've got a question, you want to pop in, please use the controls under the chat session. I will follow that as much as possible, and then we will interrupt. So Dr. Stevens has been kind enough, and he can address this when he gets started. You know, if something comes up in the middle, just let me know, and I will interject, and we'll kind of go from there. So we'll get started with that in a couple of minutes. But first, I wanted to give Sheldon an opportunity. You know, it's been a while since we had the annual meeting there in New Mexico, just to kind of give us any updates, a welcome for you, any further instructions, and then we'll kick it back to Dr. Stevens. So Sheldon, you want to take a few minutes?
Matt, thank you very much. And I really want to compliment you on your efforts of leading the economics team, you and Becky both. Doing a lot of work and trying to move things forward in a very exciting and busy environment. But thank you, Matt, for your leadership on this. And thanks to everyone who was able to join us in Albuquerque August 2nd and 3rd for our annual meeting that Matt referenced. We thought it was very successful. We had about 100 more people than we had originally planned on. And so it was our largest annual meeting so far, and we think it was quite successful. We did have the report coming from the meeting was released a couple of weeks ago. It was sent out to all attendees and to our nearly 11,000 contacts that we have in our database, and it's available on our website. If you haven't seen that, didn't get it, can't find it, let me know. I'll be happy to send you a link to that. A little closer to home, you all may recall or heard communications about Steve Schaefer, the Chief Scientific Officer, had retired at the end of June. And so we've have done a national search for a new Chief Scientific Officer. We began those interviews this morning, and they will continue through tomorrow. And we hope to have an announcement, if not a new Chief Scientific Officer on staff December 1, hopefully, maybe a little later than that. But that equates to 25% of our workforce here at this institute, so it's important for us. Following the annual meeting, some of you, I believe, looking at the attendance list here, may have attended the Soil Health, Human Health Connections Conference that we, SHI, worked with a number of planning committee members and funders, 12 or so different organizations came together to help fund that, identifying the nexus between soil health and human health. We had nearly 200 attendees. It was a mix of human health professionals and academics and researchers and soil health, agricultural researchers. Admittedly, we didn't get the turnout from the medical community that we had hoped in the attendees, but the program was well balanced and I think well received from all of the attendees. We did issue a press release earlier this week identifying those 10 research priorities that came out of the breakout groups, 10 breakout groups we had. Again, if you didn't see that, it too is posted on our website. We engaged Dr. Schaefer on a contract to help us get through that conference and to prepare the final report. We should have that out by mid-December with some next steps on where to move that human health, soil health nexus forward. Looking a little bit on project summary since the annual meeting, we had a pretty good briefing there on our long-term research sites, looking at standardized measurement and across North America. We in the process of securing 140 long-term research sites. Many of those are in place. We've engaged 6 field scientists, 1 database statistician to help us with the data analysis. But those 7 professionals are in place. The RFA, request for proposal, is out for soil laboratories to conduct the upwards of 1,000 to 1,200 soil samples that will come out of those 140 sites over the next 10 months. We hope to have those labs announced and in place by the end of the year. And so that's moving forward very well. We're on the cusp of finalizing our economics farmer adoption project that we had engaged with the Walton Family Foundation. We will have a paper coming out looking at the economics, using yield as the surrogate for return, economic return, and also DAT2 research had 4 case studies that came out of that work, as well as their understanding the barriers and needs from an agriculture retailer's perspective that was released a couple of months ago. Marcy from DAT2 has briefed the economics team on a similar webinar in the past, and so that work is out there from that project as well. We have a number of other projects on water quality, that a project that's moving forward, soil sampling for that soil health connection to water quality began this week, and so be more exciting work coming out of that. Getting closer to home, Matt, on the economics action team. Again, Matt and Becky Doyle lead that team, and essentially there's 2 efforts that you all may be familiar with. One, looking at the partial budgeting development, implementation of a partial budget that could be used across the industry and doing economic analysis of soil health. And the second one, more of an off-farm connection to the soil health and soil health practices and the impact on land values. And Becky's heading up a team that is really engaged in working on that issue. To date, Matt, we've had, I believe the number is 86 or close to 90 different individuals over the last 4 years, and even dating back to the soil renaissance days that have engaged at various levels in the economic action team efforts. And so we appreciate that and compliment all of you for who have and continue to participate in the action team work. So on the last note is on the economic side that we're increasingly getting excited about is we've been working with a couple of our coordinating coalition partners. It's a group of 11 organizations that's been meeting now for a couple of years, trying to align efforts around soil health, and so we don't duplicate, but we leverage collaboration on an economics project. We're still refining the efforts and details of that, but we're far enough along that you may have noticed, hopefully the economists on the call, that SHI is looking to engage a soil health economist or an economist to help us look at soil health economics issues going forward over the next year or 2. So as those details come out, Matt, we'll visit and see how we can leverage that work with the work of the action teams. And so with that, I'll be quiet, and I do want to thank Dr. Stevens for his time in sharing his expertise today. I don't think you could cut it any cleaner than the topic of his research and his presentation, the economics of soil health. That is like cutting to the chase, and so we appreciate that, Dr. Stevens. And I see that Alejandro Plastina is on the phone from Iowa State, who has done similar work and made similar presentation to the group a few months ago. So, Dr. Plastina, thank you for being on the call as well. Back to you, Matt.
Thanks, Sheldon. I appreciate that. I'll mute you so you don't have to worry about your IT anymore. So last couple of instructions, I'm going to turn it over to Dr. Stevens. Again, you kind of got the background. Dr. Stevens is planning on taking about 30 minutes, 35 minutes or so, for discussion. Again, please use that chat if you want to chime in on something, and we'll stop as appropriate. Otherwise, then we'll turn it to Q&A and just kind of open discussion. As a reminder, we are scheduled for 90 minutes. We don't necessarily have to use it. We do not have any agenda items after the presentation and Q&A. So this time is now focused on the economics of soil health. So Dr. Stevens, I will turn it over to you.
Great. Well, thank you very much, Matt. I really want to say thank you to the Soil Health Institute for expressing interest and inviting me here. To start off, I've sort of been scrolling through the attendees list, and it looks like we've got a good cross-section of other economists and people from maybe more the soil science perspective. And so that's kind of the ideal audience for this. And I'm sure the soil scientist people are going to look at my soil science and say that's beyond the basic. And the economists are going to look at the economics and say, yeah, there's nothing a whole lot new here. What I'm really trying to do is sort of build a common understanding across these disciplines and make a statement about where I think future research can go in this and how we can think about this for public policy. So let me just quickly outline some of the goals I have for the next 30 minutes or so. So I'm going to start off by just sort of establishing a working definition of soil health. I'm not saying it's a be-all, end-all definition, but just to sort of get us on the same page about why we should think about soil health indicators rather than soil health indices, things like that. Then I want to talk a little bit about how I, as an economist, think about the different benefits of soil health, thinking about those that are private versus those that are external, and then thinking about those that are agronomic versus sort of environmental, and how that sort of influences how we can think about this. Then I'm going to sort of build an economic model of how I think about soil health. And the jargon for the economists, this is just sort of a basic discrete time optimal control model. In non-jargon, it means we're going to put together human behavior with natural processes over time, and just sort of walking through what that kind of a model can get us in terms of policy analysis. And then finally, I want to highlight sort of what are the outcomes of thinking about soil health in this way, and what are some examples from the literature of things we can learn from this sort of approach, and why am I talking about it now in 2018? Most of this presentation is drawn from a recent publication in the journal Food Policy, so the citation is on your screen there. And I'm happy to share copies of that with anyone who's interested, or talk more offline. So the way I define soil health in the paper is a measure of a soil's ability to support life, withstand transient environmental stresses, and endure as an integral component of a resilient ecosystem. I found a number of other equally good definitions in the literature. I know Maria Bowman at Economic Research Service and others have, done some good review work on this as well. The things I want to highlight in this definition that economists haven't always been good about acknowledging is one that soil health is fundamentally multidimensional. It's not naturally restricted to sort of a unidimensional index of soil health. Second, it's context specific. So depending on a soil type, whether you have a lot of clay or a lot of loam or a lot of sand, depending on your latitude and rainfall, what constitutes a healthy soil depends a lot on where you are, what kinds of activities you're thinking about using the land for, and things like that. And then finally, it's truly broader than mere agricultural productivity. And that's something that's sort of emerged over the last couple of decades that didn't really exist in at least the economic research, back in the 80s or 90s, where we were focused more specifically on fertility. As a quick point on this slide, I just want to sort of make an argument against unidimensional soil health indices. And there are sort of three main reasons I think they really restrict what we can do analytically. One, they make some pretty strong assumptions about what matters in what way. Sort of, you're making some sort of functional form assumption about what should go into your soil health index. Second, they don't naturally tell you what might be limiting a soil's health. So the soil scientists will be very familiar with von Liebig's law of the minimum, which is that any one component of a soil, chemically, physically, or biologically, can be a limiting factor to increased fertility or increased soil health. And a single index number doesn't really tell you what that limiting factor might be. And then finally, an index sort of allows you to directly compare any two soils that you can plug into that index formula, and that might be really misleading because soil health is so context specific. So if we're not going to use that, let's think about what goes into a proper definition of soil health. And lots of people do this lots of different ways. I sort of looked at the literature to the extent that I can as an economist and sort of noticed there are three major components to how anyone really thinks about this. You've got the physical attributes of soil health, the chemical attributes, and biological attributes. And within these three categories, we can sort of come up with different observable variables or indicators that can tell us different things. So aggregate stability, soil compaction, organic matter, soil pH, macronutrients. These are things that can be measured and are measured in a lot of cases. So if we're not going to use the soil health index, my proposal is that we should be focusing on a set of finite indicator variables for these various components of soil health that we can observe, and that capture the most prominent characteristics of soil health, which of course is up to some sort of interpretation, but we can sort of, we feel like we have a good idea of what sort of the low-hanging fruit are. And what these indicator variables can be is going to depend a lot on your context. So for example, if you're in a developing country context where soil analytics are expensive or inaccessible, or it's difficult to collect information, you might have a pretty simple system where all you observe is organic carbon and macronutrients. And so Leah Bevis and her co-authors have a paper from last year that sort of go through an economic study of soil health with those two indicator variables. In the developed world, in American high-intensity agriculture, we can imagine observing a whole lot more. So there's a paper from 2009 that sort of looks at a total of 15 different soil health indicators, and that's not too difficult to imagine in 2018. What's different about sort of now, and I'll get back to this at the end of the talk, is that we finally have computing abilities where 15 indicator variables aren't prohibitive for solving a model. We can actually handle a lot more information, and that really opens up this method, which had sort of died, to new research. So now I want to talk a little bit about how we can classify the benefits of healthy soils. So when you speak to farmers, sort of there's a very natural sort of private agronomic benefit of having healthy soils, and that's, you know, healthy soils lead to increased yields, can reduce pest controls, reduce the amount of money you spend on fertilizer, reduce the need for irrigation, things like that. When we go and talk to sort of environmental activists and other researchers, we might focus more on the external environmental benefits, things like the fact that healthy soils help control erosion, help clean water, help control flooding pressures, and can sequester carbon, which is sort of down here in the lower left-hand quadrant. But there are these sort of off-diagonals as well. There are these private environmental benefits. Erosion control is a private benefit. Flood control is a private benefit. You know, having a biologically diverse and beautiful farm is a private benefit to someone who lives on their farm. And then there are these external agronomic benefits as well, which is the fact that if I'm controlling pests on my farm because I have healthy soils, that helps out my neighbor because there's a lower risk for pest outbreaks or for disease outbreaks and things like that. So this, for those of you familiar with Elinor Ostrom and sort of thinking about externalities versus private benefits, this is sort of that kind of approach to this, but we're going to see this come back as an extension of the model I'm going to present, and sort of an elegant way to incorporate these external benefits into sort of a neoclassical economic model. All right, so another thing we have to think about when we're thinking about soils and putting this into math is the fact that there are important dynamics here to soil health. And those dynamics come from what I'm going to argue are sort of two main drivers. One are natural processes, sort of how does a soil health indicator evolve over time in response to its own environment. And then the second are sort of the things that we as humans do to land, to soil. So what different land management behaviors exist, what kinds of inputs are put into the soil, what kinds of behaviors are taken on a piece of land. So an example with the natural processes, the soil organic matter of a soil depends heavily on what it was last year, but it might also depend on the pH of the soil. And so this indicator depends both on itself and other indicators of soil health over time. But it also might be affected by land management behaviors, like how much crop residue is left on the field, or how much lime is applied, even if the lime is applied for a reason that has nothing to do with soil organic matter, it nonetheless may affect the evolution of soil organic matter over time. So those are things we want any model to incorporate. All right, so here I'm going to sort of go through this. This is simultaneously probably going to be pretty fast for the non-economists and pretty slow for the economists. So if there are any questions, please do use the chat box, and Matt will interrupt if anyone has any questions. There's going to be a lot of math on some of these slides. I don't really want you to focus too much on the math. If you want, you can go see it in the paper. I'm going to try and highlight what it means, but it's kind of nice to be precise when possible. All right, so I want to start off by thinking about some agricultural production function F. This is basically just a way to turn inputs and soil health into some sort of output, which we can think of as yield. That yield, that output, is going to be sold for some output price P. So for a really simple example, suppose F is the yield function for corn and P is the price for corn on a corn farm. V is going to be a vector of n different inputs. These can be really broadly defined. So it can be nitrogen fertilizer, or it can be whether you leave corn stover in the fields. So it's a pretty broad definition of what those inputs can be, but there are going to be n of them, and Z is the input price of each of these inputs. And even things that are behaviors, like leaving corn stover, do have some sort of economic price to them. And we can think about opportunity costs, or what you would have done otherwise as sort of a foregone benefit being the input price for those sorts of behaviors. And then finally, we're going to have a set of m different soil health indicators, which are thetas, which are things like soil compaction, pH, macronutrient levels, things like that. And if we put this all together, we can sort of write down what a farm's single year profit function might be. Their profit is going to be total revenues, which is output, F, times price, subtracting the costs of those inputs. So that's just sort of profit is revenue minus costs, and these variables go together in this way. The thing I want to point out here is that both inputs and soil health affect agricultural output, so they affect revenue, but farmers only pay for the inputs. Farmers can't go and buy healthier soils, right? The only way they can really affect soils is through their input decisions. And in a single period model, there's no way for that to happen. So what we're going to have to do is start thinking about dynamics and thinking about this model over time. As soon as we start dealing with multiple periods, this is sort of the fundamental insight here, is that there's a function for soil health transition, which in sort of jargon we call an equation of motion. And so that's going to be this equation G, which basically takes the inputs that I put in this year and the level of these soil health indicators this year, and putting that all together is going to tell me what the soil health indicators are going to look like next year. This thing is very broadly defined. Again, it's a vector function, so lots of things go in and lots of things come out. But we can think about partially differentiating this function and getting some really interesting components, right? So the partial derivative of this function with respect to the inputs V tell us how soil health indicators next year respond to a bit more of input I this year. And the partial derivative of G with respect to a soil health indicator J tells us how soil health indicators next year respond to a slightly higher level of that soil health J this year. And so those are things, we'll come back to this, but those are really important relationships, these partial derivatives, which soil scientists and economists together can very reasonably estimate given the right sorts of data or experimental projects. One more component that we have to throw in here, and this is sort of second nature to economists, but this isn't so second nature to people who haven't thought about this, and that's including a discount rate, which is a behavioral aspect of economics, capturing how people value things over time. And so there's this, I would say, stylized fact or understanding we have about human behavior that we value things today more highly than we value the same things in the future. So for example, if I said, I'll give you $100 today or $100 in 5 years, we expect you to say, I'll take $100 today because it's no more valuable in the future and you can't use it until you get it. So we sort of parameterize this preference over time with what's called a discount rate. And how high that discount rate is tells us just how much you value benefits today versus in the future. And just as an example, I've drawn a graph here of what your value today is of $100 over different time horizons with a discount rate of 2%. So what we see here is you'd be indifferent between receiving between receiving $100 50 years from now and say about $38 today. And that's what that discount rate of 2% tells us. There's a whole strand of economic literature looking at what people's discount rates are and what we should use for modeling things. But I'm just going to leave that sort of for future debate and say there's some delta greater than 1, which is going to tell us how farmers or land managers in general weigh benefits over time. So now we can sort of pull it all together into what's known as an optimal control model. There's lots of math on this page. I'm going to walk you through it. Don't let your eyes glaze over. So we can think of someone who owns a plot of land and is farming it or managing it as sort of a productive part of their livelihood, sort of have to solve this infinite horizon problem of what am I going to do to this land this year and next year and the year after that, and all of those sorts of things. So what they're going to do is they're choosing inputs in every time period from today sort of on to foreseeable future. Those inputs are going to sort of determine what output is through the production function f, which determines what revenue is when you multiply it by p. Each of those years you have to pay for those inputs. And so what you see in the brackets here is basically each year's profit. And so there's this infinite sum of these profits, but each further year in the future, you sort of count those profits as less valuable to you today because they're further away. So this sort of makes this infinite horizon problem tractable because you get far enough in the future with a high enough discount rate and you basically just don't care. An example is, I just don't care what's going to happen 200 years from now on my farm because I won't be around and it's just too far in advance for me to really to care about. So that's sort of what the farmer's trying to maximize, is this stream of profits over time, but the farmer's constrained by a couple of things. First, you can't use negative inputs, even if you'd like to, right? So you can't take nutrients from the soil and get paid to do so. You're sort of stuck adding things to the soil or taking action rather than untaking action. And then the really important constraint here is that this function g tells us how soil health is evolving over time, how these indicators are evolving over time. And the farmer's sort of stuck with how the world works. You can't change biology, you can't change chemistry. So that's sort of the unconstrained problem. We can turn that problem into something that's more or less easy to solve by putting in what's called Lagrangian form, which is just here at the bottom. If we want to talk about it, I can talk about what these Lagrange multipliers mean. They have really nice economic interpretations, but I'm going to keep moving for right now, and we can come back if you have questions. By putting together a Lagrangian, we can take some partial derivatives and come up with what are known as first order conditions, or in layman's terms, sort of these 4 conditions must hold for any solution to this problem as we've set it up. So I've got the 4 conditions here, 1, 2, 3, and 4. Let's start with 3 and 4 because they're basically straightforward. 3 just tells us we have to have positive or non-negative values for inputs. And 4 is basically that we can't break science. This G function really determines how soil health evolves over time. The economically interesting conditions are 1 and 2. So the first condition here is just an ugly way of saying that there's this balance between the costs and benefits of a single input's effects on immediate output and that input's effects on soil health. Remember, the farmer can only affect future soil health through their input decisions. And so there's this sort of trade-off between using inputs for immediate sort of output and revenue purposes and those effects on future soil health, which may adversely affect future output. And then the second condition balances the dynamic value of having healthy soils over time. And this is sort of the key intertemporal condition that says there's a trade-off between investing in healthy soils today and maybe taking a hit on productivity, but then having healthier soils in the future and having more productive soils in the future. And that intertemporal decision sort of comes here in the second condition. If you have numbers for all of these things, you can take these 4 conditions and sort of solve the model. And that's kind of a hand-wavy statement. So I'll get to some examples in a couple slides, but what I want to sort of point out here, especially for the non-economists, is that what matters in this sea of math are these 4 relationships, which is how crop output changes with slightly higher levels of inputs or slightly higher levels of soil health, and then how that soil health transition function is affected by both inputs and sort of initial soil health conditions. So these 4 relationships, these partial derivatives, these are things that a soil scientist who's running an experimental plot, or even an economist who has good data from say, a farmer's history of land management techniques can estimate and sort of get a sense of what's a mathematical approximation of how corn output responds to higher levels of soil pH or something like that.
Dr. Stevens?
Yes.
A great question, which is perfect timing for this particular slide, and it has to do with the land manager and private land management. The question is related to the role of discount rates in your model in rented versus owned land. Maybe if you could take just a minute to talk about that.
That's a great question, and it's very much on point. The short answer is the model makes most sense for someone who owns a piece of land. We can think of there being this sort of agency problem between a land renter and a land owner. I talk about that a little bit more in the paper. I think as a sort of baseline model, thinking about this way is sort of a useful way to get the quote unquote right numbers. And we can sort of think of that principal agent problem of land renters and how do you align incentives between a renter and an owner as sort of a secondary economic question. Or you can think about different ways to design contracts. You know, rather than cash rents, do you do crop share agreements that align those incentives better? But it's a great point that if you've got, say, a land renter who's paying cash rents and really expects to not be farming the land 5 years from now, this doesn't really make much sense as the right model to write down. But I think whoever owns the land, even if they're renting it out, this is probably the right model to think about how they should value things or how they'd like the person farming the land to be thinking. So I can talk more about that maybe in question and answer, but that's my immediate response, and it's a great question.
Perfect. Thank you.
Yeah. What I want to sort of tie together here on the second half of this slide is that this kind of model draws together a couple of things that I think are really powerful. First, it pulls together the human behavior of profit maximization, which I think I'm biased, I'm an economist, but I think tells us a lot about how people make decisions. Second, it brings into the conversation these land managers' time preferences. So it's really easy for us sort of in our ivory towers to just sort of pretend that discount rates don't exist and that, you know, just looking at the biology or just looking at the chemistry over time is sort of self-evident. But we as the academics don't manage the land, and people do. And so we want to think about what matters to people and how they think about this intertemporal decision. And then finally, and this is the really important part, is that it incorporates the dynamics of the natural processes. And this is, I'm preaching to the choir here, but that's sort of the crux of what makes soil health difficult, is you can't just snap your fingers or make a huge investment and make your soils healthy. It's a dynamic, decades-long process in a lot of cases. So I want to go through just a couple of examples, because I know that was all somewhat abstract. So here's an example sort of from, I'd say, the golden age of these kind of models in that agricultural economics literature. So this paper from Burt 1981, which was published in the American Journal of Agricultural Economics, was studying wheat farming in the Palouse region of sort of eastern Washington and northwestern Idaho. Beautiful rolling hills there. Wheat is sort of the primary thing produced. So in this setting, he estimates a model very similar to what I've outlined, but there are very, very few variables. So there are only two soil health indicators. One is the depth of the topsoil, and the second is the percentage of organic matter in the top 6 inches of the soil. So those two variables are sort of summarizing all there is about soil health in this case. And then the input decision is actually only a single variable, and it's the percentage of a farmer's land that they plant to wheat. And the idea here is that in this case, planting more wheat depletes soil health more quickly than leaving more of it fallow. And the result of running this model in this sort of case is that Bert's able to sort of map out what these optimal decision rules are for a farmer who sort of faces a given price for wheat and faces certain conditions for his soil. So, for example, this is a figure out of that paper, sort of the output of the model. So you look at this graph as a farmer and you say, oh, well, I've got topsoil that's 9 inches deep and I've got 3% organic matter. I should be planting about 75% of my farm to wheat if the price of wheat is $3.20 per bushel. And that's sort of going to be an optimal decision conditional on looking over time into the future, the dynamic processes, this, that, and the other thing. This graph would change if the price were different. You'd probably see people planting more wheat on less healthy soils if the price was higher, and vice versa if the price were lower. But this is one sort of thing that can come out of a model like this. Now, I mentioned earlier in the talk about these private benefits versus these external or public benefits, and how could we incorporate this into this sort of framework? Well, I'm realizing this isn't showing up as well as I had hoped. I put things in maroon that were new, and the maroon doesn't just show up very well. But we can change sort of the objective function, or the thing the farmer's trying to maximize, by adding a benefits function B. And this is some sort of function that quantifies the external benefits of having healthy soils. So now this is no longer the farmer's private problem. This might be a social planner's problem of how can we incorporate these public external benefits with the private benefits the farmer sees. You go through and you solve the model, and the only thing that changes is that second optimality condition where we see this partial derivative entering that second condition. In general, what that's going to mean is that an optimal solution is going to invest in healthier soils earlier than they would without those external benefits. And if we have numbers or functions for all of these things, we can actually quantify just how different that sort of socially optimal solution is from a privately optimal solution. Another way of saying that is that this can quantify the market failure of these externalities not being internalized by a private farmer. And I know that's throwing a lot of econ jargon around. I'm happy to talk more about that in the question and answer. So I want to convince you that this kind of an approach provides some insights that we don't get from a lot of the current research or other approaches to studying soil health. A big thing here is that an optimal control model, because it has output price here as a component, can help us put a dollar valuation on various aspects of soil health. And so a really good example of this, there's this working paper by Berezhneva et al. And I can share contact information for her. It's a very nice demonstration of this using a model like this, and it's approachable, is studying a maize-based agricultural system in Kenya. And what they find, estimating a model like the one that I've outlined here, they basically see that these Kenyan farmers have a entirely private value of about $27 and $47 per milligram of carbon dioxide equivalent. And if you compare that valuation to other numbers out there, it's a lot higher than carbon market prices, and it's in about the same ballpark as estimates of the social cost of carbon. And sort of the takeaway from that is that these farmers seem to be valuing their soil carbon at or above sort of what we think the social valuation of that carbon should be. And so this might be a case where there isn't a huge externality problem of carbon in the soils, and that most of the benefits here are private. So some general takeaways of approaching questions in this sort of way. One is that thinking about socially optimal public policy, what that socially optimal public policy is going to depend really heavily on whether and how much the benefits of healthy soils are sufficiently external to the landowner or the land manager. If most of the benefits of having healthy soils are private, which there are some compelling reasons to think that's the case, there's not a super large economic justification for policy interventions. Since in general, we sort of think economic policy is justified when there's a large market failure or a significant externality. I'm not saying there aren't externalities, but it's sort of an empirical question which we can start to answer. The second point, and this sort of gets to that renter-owner distinction, is that discount rates are really important. So if we think that society as a whole has more or less the same discount rate as land managers, we don't have a very big problem. But if we think that society maybe values the future more than a private landowner does, there might be a wedge between what socially optimal behavior is and what privately optimal behavior is. I think there's a paper at McConnell from the 80s as well that sort of digs into that question a little bit, but that's something that's been under-researched as well. And then finally, I want to make the point here that the model I put together, I highlighted that there were those 4 partial derivatives, how the production function changes with inputs in soil health, and how future soil health changes with inputs in soil health, that really determine what optimal behavior are. It's kind of a heroic assumption to think that most land managers actually fully understand what all of those intertemporal dynamics look like, or even what their own current soil health is. And so I think probably the strongest argument in favor of economic policy intervention in this space is to subsidize or make much more accessible just information about how healthy your soils are, what your soil health indicators are, and how they respond to things over time. I work at a land-grant university, and so this is preaching to the choir a little bit, but there are huge returns to these public investments in information dissemination, and education among our land managers. All right, I think I've got 2 slides here, and I just want to talk about why did I write this paper now? Why am I talking to you about it now? Optimal control models have been around for a long time. BERT, sort of that 1981 paper, was just this lovely example, and I'm not really doing anything drastically different from that. But a couple things are different now. First, we have a much more holistic understanding of what soil health means. It's not just fertility anymore. We understand that there are these environmental external benefits that we're not capturing if all we care about is yield. Second, soil scientists have been plugging away for decades and have a much better, more comprehensive understanding of what these dynamics look like. Those partial derivatives are things that we can estimate much more accurately now than we could in the past. And then finally, and I think this is a big one, computers are cheap. Computing power is much cheaper, more accessible than it was in the past. And so when Bert in 1981 solved his model with 3 variables, that was computationally expensive. It's not so anymore. We can do much more complicated models. We can incorporate all the information, all the data that we can gather on soils and present a much more complete, more precise picture than we could in the past. And so sort of what's the call to action? And I give a lot of credit to the Soil Health Institute for convening and sort of empowering these movements to go forward. I think there's a great opportunity here for a renaissance of collaboration between soil scientists and economists. In order for that to be fruitful, first, I think we economists need to learn and understand the multidimensional nature of soil health. We are, by nature, we want to simplify things as much as is practicable. And so indices are always really attractive, but I think they miss some really important aspects of soil health. And so we need to think multidimensionally. Second, I think soil scientists, and I might be speaking out of turn here, but if they want to be more policy relevant, need to acknowledge that human behavior is a really important component of how successful policies are going to be at achieving the intended outcomes. And so working with social scientists, unbiased, I think economists do a pretty good job of this, is fruitful for making the soil science insights policy relevant, putting dollar values on things, quantifying things in a way that makes sense. And then finally, the immediate need are sort of these good estimates of what these marginal effects are, how output changes with inputs and soil health, and how soil health transition changes with outputs and current soil health indicators. Those relationships, we have some of them in the literature. We certainly don't have a complete set, and we certainly don't have a complete set using sort of state-of-the-art methods that give us really good estimates of what these things look like. And I'll put on an asterisk here in saying that these relationships certainly change depending on context and location. So just because I might work with someone in the Mississippi Delta to look at these things, those numbers are not very indicative of North Dakota wheat country. And so again, I think there's huge benefits. The system of land-grant universities across the country to produce some really good numbers that are context-specific and designed for some of this interdisciplinary work. So that's what I've got prepared here. I see there have been a couple of comments in chat, but more broadly, I'd just like to have a conversation. And once again, thank you to Matt Bechtel and the Soil Health Institute for inviting me.
Thank you very much. Just a few quick things while people are starting to type questions. And again, just as a reminder, shoot me a question in the chat, or if you just want to get unmuted and engaged directly, please let me know. With this many people, that just becomes dangerous to unmute everyone at the same time. But a few things. I mean, we have had some wonderful webinars in the past, very much boots on the ground. Dr. Plastina, the Day 2 work, and others. This is exactly what I had hoped for, a bigger, broader discussion on kind of where are we at the economic side, at the higher level of order. And so I'm excited about, kind of the opportunities that this conversation brings. One other question that came up, you dealt with the discount rate question. That was one. One was, the question was also curious to know if you have a measure for how farmers factor in assumptions about increasing soil health based on previous practices.
Yeah, so I'll sort of answer an adjacent question. I don't have a very good direct answer, but in the paper I spend a couple paragraphs talking about some work that focuses rather than what are these actual transition matrices? What are the actual functions that describe the world? And looks more at what characteristics of a land manager suggest that they are likely to adopt a new practice or to innovate. And then you sort of look at education levels or age or other things about the person that might predict whether they behave in a certain way. I think that research is really complementary and important. I'd say it's sort of the other side of the coin of what I'm presenting. So to sort of take another step back just to think about how economists think about technology adoption in the agricultural space, you sort of either look at it, what are the economic conditions that would lead sort of anyone managing that land to make a certain decision, which is sort of what I presented in this talk. And then there's sort of the much more behavioral side of, yeah, but people aren't Homo economists, people are Homo sapiens. They make interesting choices sometimes, and perhaps we can predict who's going to make what kinds of choices based on information we know about them. So surveys that ask about people's dispositions, people's beliefs. I have some other work sort of in a totally different context about how people's social networks really influence whether they adopt a new technology or not. That's sort of an entire additional, parallel, complementary approach to thinking about these sorts of things. An optimal model sort of just says, if everyone faces the same rules, here's how we would expect them to behave. That's probably true on average, and it's probably wrong in almost every specific case, if that makes sense.
Yeah, no, I appreciate that. And again, for those of you that might have questions, I think I'm going to open up the mics here just in a second. We'll take that chance. But I'm unmuting Sheldon right now. One of the things I sent him, which I appreciated, there's a few things. I mean, the context specific, commentary you had on that, that's clearly near and dear to our hearts. The folks that attend these meetings are very quick to point out that the economic variables in Western drylands versus the Midwest, where I am sitting in a swamp right now, are vastly different. But like the one bullet you had there to me just screamed Soil Health Institute. And that was the bullet point on the optimal private behavior depends on accurate and accessible information about a soil's current health. And that's right in the mission of what the Soil Health is trying to do, among other things. And Sheldon, I don't know if I sent you a quick note. I don't have a chance to react to that, but that to me seems to be an anthem that I would appreciate maybe the other economics focused folks to really hear.
Yeah, Matt. I mean, this whole presentation has been spot on, and Wally and Maria and other economists on the phone, Dr. Stevens, to get to that point and Wally, Maria, don't let me mess this up, but getting actual on-farm data and understanding the inputs and the changes and the results of that compared to historical data, getting those real numbers seems to be the challenge. It's encouraging to me. I think this is the most comprehensive, and I'm not an economist, and you all know that, work that I've seen, Dr. Stevens, in pulling that together and showing those interactions between the inputs and the outputs and the variances there. Yeah, and I think this is spot on. And what I was intrigued by, some of our other project partners, American Farmland Trust, Nature Conservancy, that are working on that more social side. We're working on the on-farm, soil health science side. They're working on the adoption, landowner adoption, but also big efforts on the non-operating landowners, understanding soil health and, the economics of on-farm to their farmers and ultimately, maybe to themselves, and increase cash rents and or increase value over time of their asset. So it looks like those connections are all in here, again, overlaid with that economic or the environmental value and the environmental services value of that. So I've been impressed with the comprehensiveness of this, and I say my mind is swimming a little bit with all the formulas in that, but yeah, I think that one paragraph, Matt, to your point, just hones in on exactly where we're trying to help, what we're trying to do.
Yeah, so let me do this. I'm going to take off the mute button right now, and so we'll do our best to just kind of jump in. But if you've got a question, just kind of state your name and your question, and then we'll try and deal with any kind of background noise and such. So I am going to unmute everybody. So if anybody has a question, please jump in. Before we start, I guess there's one question that just came in from Brett Norman. Looks like this question relates to discount values for soil health and some of the players in that in terms of food consumers and others, and how we maybe bring them into the equation.
Yeah, so I can say the Economist line on that is that the way that consumers sort of communicate to producers is through the price that the producers receive, and that shows up in the model. The model isn't focused on that. It sort of takes the market prices, sort of some external variable, and we can think about if consumers tend to value foods that are grown more sustainably or that are less impactful on the environment, that they might demand a higher price, and sort of that's how producers would be basically told through the market signal that consumers value those sorts of things. On the discounting side of it, I think it's less of a consumer-producer distinction than a private individual versus a public societal decision. So I think, and there's been a lot of academic work on this and ongoing discussion about sort of, you can think about, you have to make your own decisions about how to plan for retirement and how much money you want to have at different stages of your life for all the uncertain things that come. And then there's sort of this public discussion about, for example, how much national debt should we have? At what point is it too much? How much do we want to be spending on program X in 20 years? And that those intertemporal decisions may not match up. Just because society may, and for myself a little bit, society may actually value 2 generations in the future more than an individual might value that same generation. I can point people to some of the literature in that, but in general, I don't think it's as much consumers producers as it is producers versus society in general.
Yeah, if there's some links, I think we'd be happy to share those as a follow-up. I think the question gets into kind of the terms of premiums in food production and what people might be willing to pay for some of these movements and such. So I think we can hit that more. Renee has a question. Renee, I'm going to turn it over to you to ask your question.
Yeah, Andrew, thank you very much. I had a question around what kind of external interest have you had in this work? In particular, I've been doing work with the investor community, and I'm just kind of wondering if you've seen some interest from the investor space.
Yeah, so I mean, I came at this from sort of the modeling perspective, actually. So we use very similar models when we model things like groundwater use and thinking about some of these other environmental questions, and sort of it was a natural way to apply that kind of thinking to soil health, which is this renewable resource that takes time to evolve. On the investor side of things, I've had sort of tangential involvement, and I've heard a lot about, I think there's a lot of interest in soil management and soil health behavior as a component of climate adaptation, so through, or carbon sequestration, right? So the idea of putting more organic matter into the soils, taking it out of the atmosphere, or preventing it from being released into the atmosphere. And I think on the investor side of things, that's where I sense there being the most interest as soil management as climate strategy. My 2 cents on this is that the thing that I think a lot of people on this call probably understand, but a lot of people don't understand, is that land management in terms of climate policy only makes a big difference if land management changes are permanent, right? So if you plant stand of forests instead of farmland, but then in 10 years you just pull up the trees and plant farmland again, that carbon is no longer sequestered. So we can get into technical conversations about whether sequestering it these 10 years is better than the next 10 years and things like that, but it's good, it's all good. The question is it a silver bullet? And I tend to think it's not as much of a silver bullet as some people in the investor space hope it is. And I think looking at, say, some of the case studies out recently at what those private valuations of the soil carbon is versus what the public valuations are, suggests that there isn't all that much room for behavior to change very much at the prices that it would happen at, if that makes any sense.
Great, thank you. We also have a question from Maria Bowman. Maria, I'll let you go ahead.
Hey, Maria.
Hey, Andrew. I really appreciated your model because I feel like I've been thinking sort of macro and federal policy and federal data for a long time, and it was good to go back and think about some of the dynamics and the ways that we think about the interactions between input use and management practices and soil health. I guess one of the things that I struggle with a little bit is, you know, at least at the federal level, and also I think to some extent at the farmer level, people think about things in terms of practice adoption or, you know, things that you can see or do instead of the soil health indicators, which, you know, for the most part, we haven't been measuring over time and don't have as strong of an understanding of their relationship to the yield response or the profit function or those types of things. And one of the things I've been thinking about is, so if you think about it from the practice adoption standpoint, implementing a cover crop is also going to have impacts on yield and profit that may not be affected through a change in soil health, right? So like if I have weed suppression due to having a cover crop, that may or may not be a direct result of changing a soil health indicator. And so I guess that's one of the things I've been struggling with is, are the measurable benefits always being transferred through these indicators that we can observe? Is that the right point to focus on, or do we need to be thinking about it as there being like some intermediate steps or some other pieces of the process that are, you know, more looking at the practice adoption and that also having benefits that are correlated with soil health? And I don't know the answer to that, but I liked the fact that you focused on the soil health indicators because usually I feel like it goes the other direction. So.
Well, yeah, thanks. I mean, I'm trying to find a slide that's not too scary. I think that's a really good point. And I think the model is, it's very easy for me to talk about because it doesn't get into the weeds, right? It's very, you assume that all of these things exist and are observable and you already have the numbers and then you can solve the model. And much of the really hard work is actually putting numbers on all of the components. One thing I want to point out is that this production function F, and we can think about that as you go talk to your agronomist expert at the land-grant university who specializes in corn, and that specialist is able to tell you how your corn yield is going to respond to different levels of fertilizer and different, say, levels of soil compaction or something like that. That this partial F, partial V, if one of your inputs is planting a cover crop, that cover crop should directly affect output, but it should also affect how potentially different soil health indicators evolve. And so that's where, in any particular application, this is where I think the real tricky work is, and I sort of glossed over it. You know, if I partner with a soil scientist here in Mississippi to do something, for example, you want to design a data collection experiment or, you know, research project that's going to be able to get all four of these things sort of in the right way that doesn't double count them in the wrong way. I think so the real takeaway here is if we can get some number for all of these, we can start estimating these models, and that's going to be preferable to some of the stuff that's out there right now. But if we want to do this right, it's actually going to be pretty labor intensive to feel really confident that the numbers we have for all these things are actually things we want to pin our hats on.
Yeah, thanks.
And a quick shout out to everyone else listening. Maria has another review paper on soil health and economics that looks at things from a different perspective, and I just want to give her a shout out and send people over to that as well.
Thanks, Andrew.
We'll get that one on our webinar next. So I don't have any more questions, but one last just comment, maybe just an open discussion. I sent a couple of links. I'm going to try and find them real quick here. John Wiener sent a couple of things. One was on this study and work, which I had heard of but don't know a lot about, so maybe we've got some folks. This is the Farms Under Threat work that was done by American Farmland Trust. NRCS was involved. And then the other link he was talking about was Earth Economics and some of the work that's been done there. So I don't know, John, maybe you want to make a couple of comments to see if folks have discussions or input on that, if we have any experts. And I think I unmuted you. I accidentally muted you. Go ahead. Okay, so we might have lost John, but I'll make sure that those links are prepared and in the follow-up email that we have. So I'm going to say last call for anybody that has any questions or any further comments. It looks like Dr. Plastina just put in a note about anybody know how many tillable acres in the nation are appraised using soil health indicators? Anybody have any thoughts on that?
So I know that NRCS is working on soil health indicators. In terms of current surveys, we also ask people whether they test for NPK. We don't ask about what their NPK values are. We've actually started asking in our surveys about soil organic matter and whether people are testing for it and what their values are, but we haven't done anything with those numbers yet in the ARMS survey at ERS. So.
Okay, it's a good one to kind of keep in mind, and I'll make sure to include that in the running questions. Just a quick note from John was that he had some kind of microphone and phone issues, but the comment is that land quantities in the farms under threat seem very good, and the Earth Economics work seems very good as well. So just a couple of resources. I will provide those links in a recap. Anybody else? Last call.
Yeah, Maria, I had a question just following up on that.
Sure.
What about internationally? Do you see other countries utilizing that data, and if so, how? This is Renee.
I actually do not know the answer to that. If anybody were doing it, I would think it would be Australia and New Zealand in terms of some of their land care stuff, but I do not know the answer to that question.
Okay, well then I think we're going to wrap it up. Dr. Stevens, thank you very much. This is a wonderful conversation, and other than the squiggly lines, I was happy to see the theoretical part that I could at least follow as a quasi-economist. I know we've got a lot of other folks on the line. I'm going to make sure that you've got contact information. For those of you, a few of you have asked, I included an early draft of this paper in the email reminders. Now that it's been published, obviously you can go through that route to make sure that you get the authoritative paper from that organization. We can send you to that as well. But if you do have other questions you want to get to us, let me know. We'll make sure that you can get directly in contact with Dr. Stevens. And Sheldon, I'll work with you, and I'm sure we'll recap, but hopefully we can incorporate more conversations like this with the annual meetings. I think non-practicing economists can definitely consume this at this level to understand how the macro and the boots on the ground fit together. So thank you very much to everybody. Appreciate your time. Sheldon, any closing comments for us?
No, I just think that tremendous utility here, Matt, and look forward to working, with you and the team and Dr. Stevens and others to make sense of it and move it forward. Thank you for getting it all put together.
Thank you for having me.
Excellent. So I will recap with some links and things like that. We're working through how we best distribute this. Bloomfire is our preferred utility, but I know that not everybody has access to that. Obviously, I addressed that in our email. So we're going to work on that. We'll be back in touch with you very, very soon about these things. But in the meantime, if you've got some needs, just shoot us an email. We'll be happy to be in touch. So thank you again, and thank you again to Dr. Stevens. We'll be in touch soon.
Thank you.
Thanks, everybody.
Thank you, Matt.